Okay, so yes, just a couple housekeeping things. Make sure you do your data camp homework. The first 3 chapters, as listed out in data camp homework week 1, are due tonight. My hope is that each chapter is around 35 to 40 minutes, something targeting no more than 1 hour. Okay, and I aim to assign around 3 to 4 chapters per week. So the first set of chapters are due tonight, so make sure you do that. And then I've assigned, I think, 4 chapters for week 2, so you can take a look. And you'll notice a lot of these things I assign multiple chapters from the same course, and you can kind of complete the course if you just do maybe 1 or 2 additional chapters. And in data camp, if you complete the course, you get like a little certificate. I don't know if those certificates count for anything, but certainly they can be helpful. One thing I want to encourage, okay, with data camp is, I guess, take your time to read and, maybe take notes on a little piece of paper next to it, or like a notepad or something. There can be a tendency to just try to blitz through it and just try to find the right letters to type into the blank, right? So you have it kind of leaves like a little outline, and you just kind of fill in the blanks, and you won't get as much out of it, I think, if you take the approach of just trying to get it done for getting it done. But if you, the point of assigning it is to help you learn. Okay, so that's my hope, right? And it's a pretty valuable thing in terms of I think it's a pretty good website, and so I consider ourselves lucky to be able to get 6 months free basically for this. In my opinion, a pretty good product. Okay, well, anyway, what I wanted to do today is I wanted to do just a little bit of a demonstration and just lead a small example of how we can use ggplot to start exploring some data and see what some code might look like. And so I've written this RMD file that you can, I guess, download and open, and you can use it to follow along. And maybe perhaps what I will also do is I'll just kind of end up rewriting some of these lines of code. So I'm going to create a kind of a new R Markdown document. Okay, so if you create a new R Markdown document, this is kind of what it pre-populates. And so this is a good troubleshooting step. A lot of times as students do their homework, they run into issues and they say, hey, I can't get my document to knit. So one good troubleshooting step that you can do is in RStudio, you just say, hey, I'm going to make a new document, right? So you can go to File, New File, and you have a few choices, and one is the R Markdown. Let me see if I can make my screen a little bit. Oh, it's already at 150%. Okay, well, I don't want to make it any bigger. Okay, so you can kind of just click from this drop down that says New Documents, and you can do New R Markdown Document. And you can do PDF. And one thing that you can kind of use to troubleshoot is before you do anything, you just click the knit button here. Okay, and this will just kind of see if there's anything wrong with, say, your LaTeX, TinyText installation. Like, are you even able to knit documents in the first place? Okay, and so here I'm going to just call it, test. And I will go ahead and hit and save that, and I'm going to go ahead and click knit here, and uh-oh. So Okay. And so what we want to see is we want to see this thing get knit. So before I've done any kind of changes, indeed, the document knits. It produces a little table and a little plot, and so that's a good sign. Okay. So that would be an indication to me that the that my knitting setup is working just fine. Okay, and then so if I run into problems with knitting a document, then I know it's kind of like on me and not the computer, right? So and that like I've written something bad in my document, and that's why my document is not knitting, not because my computer is not able to knit documents. Okay, so so I always just say create a blank document, and then and if that works, then you can go ahead and continue. Okay, so I wanted to do a little bit of a demo here, and just kind of you can follow along if you want. You don't have to. So here I created a new document. I'm going to just kind of delete some of the stuff. I'll change the title to just say like in-class demo for week 2 Monday. All right. And then so we'll just, I guess I'll call this part 1, and I can just kind of test and click knit here, but I won't actually, I won't do this every single time because knitting, you know, it takes a bit of time, so we're not going to do this. I'm just going to go ahead and just kind of get through it here. Okay. So the first thing we have to do is we have to load up. All right, so here's my new document that has nothing, right? It just got the new title and this. Okay, but anyway, the first thing we have to do is we have to load a couple libraries. Okay, so libraries in software are kind of like recipe books. They're kind of like cookbooks, and you can think of you know, buying a cookbook, and you say, okay, well, today I want to make I don't know, beef stew. And so how do I do this? You can grab the cookbook and you open it up and there's a recipe for it. Okay, libraries have basically functions, which are kind of like our recipes that allow us to kind of do things and use things. And so we often have to say, all right, we're going to use functions out of this particular library or particular book. Okay, so in your R Markdown document, you can write regular old text, and you can also create a code chunk. So to insert a code chunk, you click this little button here, all right, that says insert a new code chunk. If you hover over it, it shows you the little keyboard shortcut. So on a Windows, it's Control-Alt-I. I think on Mac, it's Command-Option-I. So I'm going to click that. I'm going to say I'm going to insert an R chunk. And what it does is basically it puts in 3 little tick marks, curly brace R, curly brace, and then 3 little tick marks here. So you could also insert a code chunk manually by typing in 3 little tick marks, curly brace R, curly brace, and 3 little tick marks, okay? And RStudio is smart enough to recognize that this is a code chunk, and it kind of colors it in gray. And so kind of the first line of code that we're going to do is we're going to type in library tidyverse, okay? And I think that's already your very first line over here. Now, and then to run it, okay, you can click this button, run, all right, and you do run selected lines, or you can just hit Control-Enter, or what I like to do is I like to hit this little play button that says run this current chunk, okay, and if you run the current chunk and it runs correctly, you should see this output, right? If you get an error that says library tidyverse doesn't exist or something, that means you need to install tidyverse. So did anyone encounter this error where it says tidyverse does not exist? Or, okay, so if tidyverse does not exist, then what you need to do is you need to install it. So you'll come over here to this packages tab over here, okay? And you'll click this little button that says install our packages. And the package you want to install is tidyverse. And then you'll click install there. Okay, so you can go to the packages, and then there's the install button, and you can type in tidyverse, or into the console, you can type in install.packages, quote unquote, tidyverse. So that's another way to do it. Okay, so, but yeah, you just kind of, on the right-hand side, I'm not sure how your screen is set up, but you probably have like 4 windows, and I think over in the lower right-hand by default, one of the tabs is packages, and then you'll come over here and you'll click install. Is that how your screens are set up? Yeah, okay. Okay, so anyway, once you do that, and once you run install there, then you should be able to run this command library tidyverse, and it should load up. Okay, let's do, we're gonna load up another library. This library is called Gapminder, okay? And Gapminder contains data, okay? So there's a few ways to get data into R, all right? So there are packages that have data in them, and that's what we're gonna do here. You can also like load data. You can put, get a CSV file, download a CSV file as some kind of data file, and you can have R read that data in. But for this one, we're gonna use the Gapminder library. So I'm going to do library Gapminder, and then I'm going to do data Gapminder, right? And so I'm going to run those 2 lines of code, and that will load Gapminder, the Gapminder data set into my environment. Right? And so when you do that, you'll see this little thing. Again, if you run into an error where it says like library Gapminder doesn't exist or something, you'll go to the packages, you'll click install, and you'll type in Gapminder, right, as the package that you want to install, and then you'll click install. Yes?
What does it mean when you run and it runs, but like the thing doesn't show up in the console?
What do you mean by it doesn't show up?
Like nothing shows up. Like it runs and no error message comes up.
Well, great. That's like do you see the little, like it says library and data Gapminder like this? Yeah. Okay. So yeah. What that means is that the code ran, and this code does not produce output to the console. So there are different things that you can do. Sometimes you run a function, you run something, and part of the instructions say, hey, send a message to the user in the console, okay? And other times it just says, hey, do this thing. You don't need to tell anybody, right? Just do it, okay? And when we can tell it actually did something, because over in the environment, this little Gapminder pops up here, which wasn't there before, okay? Which just means the Gapminder got loaded, but it's not like it has to declare it to everybody. So if you're not encountering an error message, but you do see it in here, that means something ran here. Okay, so one thing we want to do is I just want to kind of take a look at this data set. So what I can do is in the environment, I'm going to just click this Gapminder here, and when I do that, it pops up. Okay. Another way you can take a look, I think if you click it again, it will run view, and it will appear here. Okay, and so this is kind of like a spreadsheet view of the data set, and we can see there's some information that it appears in this environment tab. You can click this little blue button here, and it expands it, and it says, here it says 1,704 observations of 6 variables. And if you hit the little blue triangle here, or blue circle with the triangle in it, it tells you what those 6 variables are. Country, continent, year, life expectancy, pop for population, and GDP per capita. And so this just has some information about countries. And if you look at it, we have it from the year 1952, and it looks like in 5-year increments, 1952, 1957, 1962, 1967, so on and so forth until 2007. And we've got countries, in alphabetical order: Afghanistan, Albania, Algeria, Angola. It's got the continent, and during that year, what was the life expectancy, what was the population, what was the GDP per capita. Okay. So that's what we have. Are we able to get this loaded on our computer? Is this working okay? All right. And so, what I want to do is I want to start creating some plots. I want to start exploring the data. Now, before I forget, let me give you your first view quiz answer. Today, the first view quiz answer is the letter D. D as in dog. So I'll just write question 1 is D. Okay? Now, this is one important theme that I will keep saying over and over and over throughout this course is that data science, to truly be able to understand data and get information out of the data, you need to be familiar with the subject, okay? And so in this case, Gapminder, kind of has information about different countries around the world and has population and life expectancy and GDP per capita, okay? One major issue, all right, is that with any kind of data set like this, countries and political boundaries change very frequently, okay? And so, I'm a little bit more familiar with, some of the stuff happening in Europe than other parts of the world. But if you look at this data set, okay. So one thing you can do is, as you explore your data set, you can use this button, filter. Okay, you can click filter, and under continent, you can kind of click one of these things, or in country. Actually, there's, I guess, too many under year. But anyway, for continent, I'm going to just kind of filter to Europe over here. So again, to get this, you click in your environment, you click the name of your data set. It brings up this view. Under filter, I'm going to go to continent. I'm going to filter to Europe. Okay, and it has countries like Bosnia and Herzegovina. Okay, and Bosnia and Herzegovina was not a country in 1952 or 1962. It used to be part of Yugoslavia, okay? Yugoslavia until 1995. And, but here it's like, oh, here's information about Bosnia and Herzegovina in 1957 and 1962. And you go, oh, how's that possible, okay? Well, if you have questions about some stuff, okay? In this case, Gapminder is a library that we loaded up here. So you can go to help, okay? And you can ask questions about Gapminder, okay? And if you go to questions about Gapminder, it gives you some details about the data, right? So here I'm going to the help tab and I'm typing in Gapminder, right? Another thing you can do is you can put in a question mark about Gapminder, and this is the same thing as looking up help on Gapminder, and it does the same thing. Okay, and it gives you a description, and it tells you a little bit about the source of the data. So here, the source comes from gapminder.org/data, and then you can click that, and it tells you a little bit more. You can read on data documentation, and it talks a little bit more about some of these things. Okay, like what about the population, and a lot of these things. It kind of draws information, from UN data and different things, and trying to get stuff. Okay, but you have to be mindful, and looking at this, you go, okay, you know what? Some of this information just doesn't. We have to be careful about the conclusions we're making. Like, for example, there's Germany here. Okay. But we know kind of during the Cold War, Germany was divided into East Germany and West Germany, and it was, reunited in 1990, and that's not reflected in the data, right? We just have Germany, and the borders of Germany changed, and then you have the Czech Republic, and Slavic Republic is something that also appears in the data. But, for many years, those two things were together in Czechoslovakia until 1993. So there's been a lot of kind of political changes and border changes and things like that. And And that's going to kind of inform us a little bit as we do some of this thing. And we just know that, okay, these numbers here, these population numbers, which are, they have it to like the one person here, a lot of these are just estimates, okay? So we might not want to take all of these things at face value, okay? And similarly, GDP per capita, a lot of these are estimates, okay? Probably pretty decent estimates, but nonetheless, we want to be a little bit mindful of that. Okay, so let's start off with just a basic plot where we say, okay, let's kind of compare, life expectancy and GDP per capita, okay? And so here I'm going to insert a code chunk, and I'm going to say what I want to do is I'm going to put the Gapminder data into ggplot. All right, so I'm going to do Gapminder, and I'm going to use this symbol, okay? Percent greater than percent, or it's also known as the pipe, okay? You can also do Command-Shift-Enter or Control-Shift-Enter, and that inserts the pipe. And what that will do is it will say, take this thing, this object, the Gapminder data, and we're going to put it inside ggplot. Okay. And inside ggplot, I want to map two of the variables in Gapminder. Okay. So I'm going to run AES, and the variables I want to map are going to be, I want to put GDP per capita on the x-axis. I'm going to do x equals GDP per cap, and there is autocomplete in RStudio. As you start typing one of the variable names, I think a little pop-up thing shows up, and you can hit tab, and it will autocomplete that name. So you don't have to necessarily type everything out, because if you do type everything out, it has to be perfect. It has to be capitalization. It's case sensitive. Lowercase, uppercase makes a difference. So tab completion really helps you avoid typos and things like that. So I'm going to do x equals GDP per capita, y equals life expectancy. I hit tab there. And then after I do create the ggplot, I'm going to say let's add geom point. We're going to add some points here. And this will be kind of the first plot I want to create here. All right. And I'm going to click run. And this is what my first plot looks like. Okay, so for those of you who are following along, is this working out okay? Or are we running into issues again? We're trying to follow along, but we're running into issues. All right, and what this is it just kind of plots all of our data, and there's just like way too many points here, and we can't really make sense of it. Okay. General trends, we see a little bit of kind of a positive trend in that countries that have a little bit more GDP per capita tend to have higher life expectancies. But yeah, you know what? It's a little bit hard to make sense of this data. So let's delve in a little bit more here, okay? And part of this problem is that we are looking at all of the data, right? Remember, the Gapminder data contains data from 1952 all the way up to 2007. So what could be helpful is, what if we just limit ourselves to just say one of the years, okay? And so that's what I'm going to do over here. Okay, I'm going to insert a code chunk. All right, and so this time I'm going to do Gapminder. Okay, Command-Shift-N, Control-Shift-M, or percent greater than percent. And this time I want to say, you know what? Let's only look at one of the years. Okay, so I'm going to do filter parentheses. And I'm going to say, let's take the year variable, and here I have to do double equal sign. Okay, so equals is used for assignment, and double equals is a test to see if it's equal to. Okay, so double equals is a test for equality, and here we're going to say we want the year equal and I'm just picking 2007. That's the most recent year in this particular data set. All right, already outdated, 15 years old already. But we'll just say, okay, let's look at 2007. All right, and you know, it's always helpful to have the data kind of open, so you can kind of make sure that the numbers you are putting in here. So let's do 2007 here. Okay, so you know, again, as you're viewing your data, you can hit filter, and for the year, you can kind of enter some of the numbers here. So I'm going to do 2007, and so this filters to 2007, and we can see, okay, we're going to have 142 entries, and we're plotting life expectancy versus GDP per capita versus life expectancy. Okay, so I've got Gapminder. So I'm filtering my data, and I just want to kind of show you, if I just run this before I do anything else, what this will do is it will just print out the data after you've filtered it. And here you can kind of see, all right, there's a total of 142 rows. It kind of shows you your first 10 rows, and each of these are little like pages and stuff of each of these things. Okay, and so what I want to do is I want to take this data of only 142 rows and create a plot with it. So I'm going to pipe this into ggplot. Okay, and in ggplot, I'm going to map GDP per capita to the x-axis. So I'm going to same thing. X is GDP per capita, tab completion. Y is going to be life expectancy. All right. And if I plot this, I'm not going to have anything. We need to add geometric objects. And in this case, I want to add geom points. Okay. And so this is a little bit easier to read, okay, because we don't have as many data points. Now we just have 142 countries represented in this thing. And we see, you know, similar trends again. Countries that have higher GDP per capita tend to have higher life expectancy. Countries with lower GDP per capita tend to have lower life expectancies, and this is kind of the data as it appears here. Is this working? Okay. All right. All right. Let me see what I did next. Okay. So to kind of help us further, we can say, all right, you know what? Let's start taking a look at some of these other variables, and can we include more information here? Okay, so I'm going to copy and paste this code and create a new code chunk. Okay, but you can kind of just expand your current code chunk. And so one of the aesthetic attributes that I want to kind of change is I want to change the color of the point. And here I'm going to color the points based on the continent. Okay, so so here I'm going to, inside my aesthetic mappings, I'm going to add a comma there, and I'm going to do color is equal to continent. Okay, and that's what I'll do. Stylistically, I like to put each of my aesthetic mappings kind of on their own line, so it's easier for me to kind of parse through it. You know, it would work just as fine if they're all on the same line, but sometimes I have a bunch of aesthetic mappings, and so my eyes prefer to see each kind of aesthetic mapping on their own line. That's just a personal preference there. Okay. So I will run this, and now we see some kind of, you know, we start to see different groups and colors here. And so we see, you know, a lot of the countries with higher GDP per capita are European countries. Okay. I guess, you know, colonial history and things like that. And, you know, there's, you know, Asia, there's a widespread in GDP per capita. Africa tends to have lower GDP per capita and also lower life expectancy in this data set. Okay, and so this is starting to reveal some information, okay, that we are seeing in our data here. Okay, there are other things that perhaps we want to plot. Okay, so I did color equals continent. So one of the issues here is that because the GDP per capita is there's such a huge range, one thing that could be useful is rather than plotting a linear scale, okay, plotting GDP per capita on a linear scale. So linear means going from 0 to 10,000 is the same distance as going from 0 to 20,000, same distance as going from 20 to 30,000. We can change the scale to be a log scale. And so rather than adding 10,000, having the same kind of increment, it'll be multiplication by a number has the same kind of distance. So what I'm going to add here is I'm going to, after geom point, I'm going to add a log scale. And I'm going to do scale underscore x underscore log 10. Right? And you can hit tab completion. And so that will change the x-axis to have a logarithmic scale. So this is what we have. So here you can see kind of the horizontal distances are approximately multiplied by 3. Okay, so the distance from here to here is just a tiny bit wider than the distance from here to here, but they're approximately multiplied by 3. So if I go from 300 to 1,000, I'm approximately multiplying by 3. Going from 1,000 to 3,000, I'm multiplying by 3. 3,000 to 10,000, multiplying by approximately 3. Okay, and so, you know, in a linear scale, the addition is equally spaced out, and in a log scale, multiplication is equally spaced out. So when you multiply by 3, then multiply by 3, and multiply by 3, you are equally spacing out. And if you look carefully, I think, does it have the same kind of axis for you guys when you create this? If you look carefully, multiplying the distance from 300 to 1,000 is just ever so slightly wider than the distance from 1,000 to 3,000. And you can kind of force the things, but it defaults to trying to pick like nice numbers that are easy to kind of work with to kind of do the thing. So anyway, this is what we have here, and it presents the data, you know, a little bit different from here, but you know, rather than having this kind of this, I don't know, this would be actually the log curve in this, you know, kind of going this way. You know, we get something a little bit more linear. There's a lot of kind of spread down here, but this portion was looking a little bit more linear. So that's one of the things that happens when you do a log scale there. Okay. Let me give you your second view quiz answer. Second view quiz answer is the letter E. E as in elephant. E as in elephant. Okay, let me see what I did next in this thing. Okay, so one, it's kind of difficult to distinguish any of these dots from each other. So one thing that could help us a little bit is to include maybe the population of the country here. All right, so if I wanted to include the population of the country, I can modify one of my aesthetic mappings. And so what I'm going to do is I'm going to say, let's change the size of the dot based on the population of the country. So let me ask you guys the question. How would I alter the size of the dot to be dependent upon the population of the country? So the variable in our data set that shows population is pop. So what would I add to my aesthetic mapping? Yeah.
Size argument in geom point.
Yeah, so yeah, we could do it either in the ggplot or in geom point. I could do add a size argument, okay? And so and I have to put it inside AES. So I could either put it inside the AES for ggplot, or inside geopoint, I can do AES size equals pop, right? So I can do size equals pop here, and that will alter the size of the dots depending on the population. Or I could put that inside this AES size equals pop. So there are different locations where you can kind of put the same thing and it will produce the same plot here. So I've got size equals pop inside here. Okay, and so a couple dots stand out as really big. We have this big green dot here, the big green dot here, and so if you had to guess, what would these dots be? They are in Asia, the largest populations. We have China and India, right? So the two most populous nations. Okay, so I believe India just surpassed China. At least the estimates are is that the population of India has surpassed the population of China. So for many years, China was the most populous country nation in the planet, and now I believe India is the most populous nation. But this is from 2007. So in 2007, China is still the most populous, and India is the second most populous. Third biggest dot over here is the United States, showing up in Americas with yellow and other large dots. I'm not entirely sure off the top of my head, but you have this is probably Brazil. This one's probably in Japan. This one might be Indonesia. So, but I don't actually know off the top of my head which of these dots are. But this is something we could add. We could kind of add additional information by tying the size of the dot to the population. Okay, so here we're just kind of changing some of these things over with the aesthetic mappings there. Okay. All right. What else did I do? Size is population. Oh, okay. So one thing is this was just from, say, 2007. And we can say, okay, well, you know what? Let's compare, say, 2007 to, say, the earliest year in our data set, 1952. Okay. And it's quite a bit different, okay? Quite a bit different. 1952. You know what? I want these plots to show up over here. So I'm gonna just copy and paste the code into my console and put it over here, and then I'm going to do the same thing for 1952. Hit enter here. And you know what? I want to. I just want to show. You can add something like. I think it's title. Okay, and you would do something like GDP per capita versus life expectancy in 1952. Okay, you can add something like title there, and that. Oh, is it not? Oh, okay. This is what we do. ggplot add title. Okay, we go on the internet and search for this. What do we do? Oh, GG title. GG title. Should have known. Okay, sorry. GG title. Okay. And that will add a title to your plot and things like that. Okay, but anyway, I have. Did I lose? Let's disappear over here. Okay. Well, anyway, we can look at this plot, and we can look at this plot, and we can see, you know what? things have dramatically changed, right? So in 1952, we can still recognize India and China as, the two biggest green dots over here. And the GDP per capita and the life expectancy for India and China, was much lower, okay? And, over, 55 years later, life expectancy has dramatically improved, and GDP per capita has also increased very significantly for these nations, right? And so sometimes you might want to say, okay, well, what does this look like? If I change it from 1952 to 1957, and it's important to kind of be aware of what your data look like, right? So if I were to put, say, 1953 in here, this data, there's no data, right? There's no data that's for the 1953. So I have to just be aware of the values in my data set, and I can say, okay, here's 1957, and this is what it looks like, and 1962. All right, so we can see life expectancy went up to 50. Life expectancy dropped. 1967, 1962, 1967. Jumped back up to something higher. And so you might say, well, can I just see all of these things? Do I have to keep changing my year and filter just 1 year at a time? Well, you don't have to, okay? So for one thing you can do, if you want to see multiple of these things, right? So I can do percent in percent, okay? So this is important. Do not do, so we've learned how to create vectors in our data camp homework, right? So we can do C for create a vector 1952, 1957, 1962, 1967, okay? Now, you do not want to you want to use this thing, percent in percent, okay? And that basically says, is the year one of 1952, 1957, 1962, 1967. You don't want to do, okay, do not do equals 1952, 1957, 1962, because this equals R does this thing called recycling, which if it does element-wise recycling, which if you're familiar with using R, you get used to it, okay, and you understand this thing and you actually enjoy and take advantage of it. But if you're expecting it to kind of do this thing where it's like you're going to test a year against this thing, it's not going to behave that way, and it can be frustrating and confusing. So it's important that you do not use equals, but in this case you do percent in percent, and it will say, is year one of these things, okay? And if we do this, it's going to create a whole bunch of these things, and it plots kind of all 4 of these years all on the same plot, okay? And so we don't actually want that. We want separate plots, 1 plot for each year, okay? And so there is a thing in ggplot called the facet wrap. So I'm going to do a plus, and I'm going to do facet underscore wrap, okay? And what this says is take this plot, okay, but separate the data into different chunks. In this case, the different chunks will be based on the year, right? So we have 4 different years in our data set, and facet wrap says take the plot that we're making, except first separate the data into different chunks. We call these different facets based on the year. And so you use tilde year. Tilde is top left keyboard button in your keyboard. It's above the little tick mark, and you hold shift for that. Okay, so we're going to say based on the year. And so this is going to divide my data into 4 chunks. And we're going to say create the plot for this first chunk, create the plot for the year 1952, do it for the second chunk, create the plot for 1957, create the third chunk, and create the same plot here, okay? And so when I do this, I will now have 4 nearly identical plots, except it is the data for the first chunk, 1952, the data 1957, 1962, and 1967. And so we can see, there's, we can look at, some of these dots, which kind of represent India and China, and we can see how life expectancy and GDP per capita changed over time in this thing, okay? And I can keep adding more of these years. So maybe I will just do kind of every 10 years, 1962, 1970, or let me do the 1957, 1967, 1977, 1987, 1997, and 2007. So now I have 6 plots. And we can see, just kind of looking at the 2 biggest green dots here, we can see how the life expectancy and GDP per capita for India and China has changed over those 50 years, okay? We can also see just overall life expectancy for the entire world has gone up from, down here the values were around the 30s, and kind of the lowest values now are in the 40s. So that's an improvement in life expectancy. We can also see GDP per capita over here, kind of the highest values were over here, and GDP per capita over time has also kind of increased. It's it's a little bit hard. These plots are just a touch too small, and we probably want to get a little bit more clarity there. But this is kind of just one more aspect you can see. And so, my hope is this gives you just a little sense and a little flavor of what data visualization in R look like. And also a very kind of important idea of just incrementally building up your graphics, right? You start off with one thing and you say, okay, can we add another aspect to it? Can we expand on this? And I guess, the best way to learn about any of these things is to just kind of play around and fiddle with it and see what kind of graphics and what kind of visualizations you can create. Okay, I think I need to give you one more view quiz answer. The third one is the letter C. C as in cat. C as in cat. Okay. So I think this RMD file is up here. We didn't get to this last one, but you can kind of see this one looks at, I filtered just to a few different select countries, and we kind of created a plot there. All right. Okay, we'll end here for today. We'll continue on talking about data visualization on Wednesday, but I hope this was kind of interesting seeing some of this being created here. All right, we'll see you guys on Wednesday.